Okay, in this video we're going to pull all of the parts that we've made for our midterm review onto a drawing sheet. But before we do so, I want to change the materials of our parts. So I have our part open here, and you'll notice that the material is not specified. We're going to right click here, go to Edit Material, and we're going to close up. Steel is probably open for you, the default. We're going to close that up, and we're going to go to the copper alloys. And down here, we're going to select leaded bronze. If you don't select the correct material, your mass properties are not going to match mine. So take a moment, make sure that you select leaded commercial bronze and hit apply. And you'll notice that the color of your part changes. I'm going to go ahead and hit save and close this guy out. You'll see that I've already done that to the other parts. You're going to need to go through each of those parts and change them to leaded bronze. I'm going to open up the assembly just so you see what happens. If there's been changes, you're going to need to hit rebuild, and it's going to make sure that all of your parts now have the correct properties. So once we've changed the properties on our parts, we're ready to begin putting them on a sheet. So we're going to go to New, select our midterm template. You're going to need to get that template. I'll set you up during class. And I'm going to close this out because I like to use this method for pulling in our parts. It's easier to see what they're going to look like ahead of time. And I'm going to go with the assembly first. We'll get a preview down here, and we're going to select the isometric view. I'm going to go back there and also pull in the exploded isometric view. Now I think this scale is a little small, so I'm going to right click on my sheet here. I'm going to right click, go to properties, and we'll make that a little bit bigger. So I'm going to go 1 to 2, and you'll see that both of these parts will scale up. Okay. On our first sheet here, this says sheet 3, but really it's sheet 1. We are going to create a bill of materials and put some balloons on here so that we can identify the parts. So under annotation, we can go to tables and select a bill of materials. I have this view selected, and I'm going to hit OK, and it's going to generate my bill of materials, which I can set right in here. You'll see that one of these has a description and the others do not yet. We'll take a look at how that happens in a bit. I want to put some balloons on here so that we can identify which one of these is the bearing, the lock nut, and the packing nut. So we're going to go to we can go to auto balloons and select this view, and SolidWorks will go ahead and put the balloons on there for us. Now if you don't like the location, you can just grab a hold of one of these balloons and move them so that they're not off the sheet. You can bring that down to here. Alright, so we should have our first sheet complete. Notice that the scale is already generated. The part author comes in because I saved this as the assembly, and a couple other pieces will get filled in as we do our other sheets. I'm going to go ahead and save this so I don't lose my place. And you should be saving your work into your midterm review folder. Okay, we got to pull in another sheet, and we need to dimension each of these parts. I'm going to start with the simplest one, and then we'll work our way up to the bearing for the last one. To create a new sheet, we're just going to click down here, and it's going to launch another piece of paper. You'll see that now there's sheet. This is called sheet 3. We can rename that so that it's maybe less confusing. Yours is probably already called sheet 1. I'm going to Let's see if I can make these match so it's less confusing. So we have our first sheet. If I click back over here onto sheet 1, you'll see what we previously did, and sheet 2 we're going to now pull in the Locknut. So I'm going to go back over here and go to Browse. Should bring us right to our folder, and I'm going to select the Locknut. Now we talked about which views make sense. In this case we're going to use this as our front view. Just because SolidWorks has identified these as front, right, and back, that may or may not be what the view that you want for the front view. Remember that SolidWorks generated this based on the plane that you drew for your sketches. So I'm going to go ahead and in this case select this view, and while I have my cursor, without even clicking, I'm just going to drag to the right and create a right side view. Now again, I think my scale is a little bit off, so I'm going to right click on this sheet and go to Properties, and I'm going to make this full size and hit OK, and now our Locknut is 1:1. Now SolidWorks has already put in this hole note, which is great, but I don't like the location because it breaks the rules. So we're going to go ahead and pull this over here, and I don't like that location. I'm going to put that, I like it like that. Go ahead and move this over, and that looks a little better. Alright, so we have our hole identified as a 2-inch diameter with a 4.5 threads per inch, so that's covered. We now need to identify our distance across the flats, so I'm going to grab my Smart Dimension and set that in, and then we just need one more dimension over here. So for this part, we can leave out all of these angles. It's identified as a nut. It's a hexagon. That's a given. And we just give our distance across the flats, our thickness, and our hole size, and we're good. So that's the easy one. I'm going to add another sheet now and pull in our packing nut. So come over here, go to Browse, select the packing nut, hit Open, and it should populate here. Okay, in this case I'm not going to select the front view because the back view actually allows us to look into that packing nut, where the front view would be generating some hidden lines. So I'm going to pull the back as front view. You can see what I'm talking about right here. We're looking into that packing nut with the threads. And then we'll select this guy. We could put an isometric in for this view. Going to hit OK, pull these down, and I'm going to rescale this so it fits in. Shade it, go with custom scale, and maybe 1:4. Let's see if we can go a little bit bigger than that. That should work. Alright, again we want to move these around so that they follow our guidelines. In this case, there's a couple other features that we need to identify, and I'm going to cover that in our next video. So our next video is going to take us through finishing dimensioning this part and dimensioning the bearing plate.